All right, Hannah, if you're listening to the recording, we're just going through the chapters 5E, F, G, and H, okay? So 5E, we've gone through the rectangular prism so far, which is just 2 times the 3 pairs of length added together, and that's the total surface area for the rectangular prism. And now we're working on a square base pyramid. Okay, what's the area of the square base? What's the area of the actual square base, Alvina? Given that the side is B. What's the formula for the area of a square with side 2, for example? What's the area of this? If it's a square, it will be 2 on all sides, right? Right? Then the area will be
4.
4, yes. How did you get 4? It's just the side times by itself. Okay? The area of a, okay guys, you guys are in grade 9, so try to remember this. Area would be, the basic one would be rectangle, right? And that's length, that's width. What's the area of a rectangle? Alvina? Correct, length times width, right? For a square, right? For a square, if you're given a side that's length B, the other one will also be B, correct, will also be B, which means the area of a square will be, Solina?
1. B times B.
B times B, that's right, it's just the same value, which means the area of the base there will be B times B, which is B squared. Okay, because when you times it by itself, it's just raised to the power of 2. So that'll be B squared. Any question? Okay, all right, now what's the area of the triangle? What's the formula for the area of a triangle? Area of triangle. What's the formula? Solina, what's the formula?
Base times height divided by 2.
Correct, is base times height divided by 2. Now let's have a look at this triangle here. What's the base of this triangle? Given that the height, if I draw the height in and put that as 2, right? What's the base of the triangle? Based on that shape there. What's this base here? What is this base of the triangle? Hint, it's a square base pyramid. The base of the pyramid is a square. This thing is a square. So if this side is B, the B there is saying that this side is B. Alright, which means this base of the triangle is Avina? What represents the base of the triangle? B, correct. Right? Because each side is B. So if you look at this triangle here, right? That's the base and that's B, and then the height is just the same as all the other triangles. The 4 triangles are the same. Okay, that's for the square base pyramid. Now let's try working through an example. Double checking, you did this one in class, right? Already, right? Okay, all right. Okay, so I'll give you guys an example for, okay, this example 10 here. All right, finding total surface area. Now note that this rectangular prism here, remember the formula is just, there are how many values? So that's the height, and let's say that's the width, that's the length, right? Remember, we're forming 3 pairs of multiplication. So we're doing 2 times 3, okay? And then 3 times 5, and then 5 times 2. Does it make sense? It's just 3 pairs of multiplication because each of them would give you the area of one side. Like 2 times 3 is the front, right? And then 3 times 5 is the bottom. And then 5 times 2 is the side over here. Okay? So 3 different sides of the same rectangular prism. And then you add them together, right? Add these 2 together, and then what do we do afterwards? After we added like these values together. Solina? Think it's on the tip of your tongue. How many sides, how many faces are there for the rectangular prism?
6.
6, correct. And we've got three faces so far, 3 sides so far. So what do we do with this value? So what do we do with that value?
2.
Times 2. Alvina, why times 2? Yes, correct. Very good. It is 2. There are 2 of each side. So just times the final result by 2. So the total surface area would be 31 times 2, 62. Note down the unit, centimeter squared. Okay, any question? No? Okay, that one's easy so far. Now, for this one, the right square base pyramid, they've given us the 3 meter there, and that's the height. Okay, that's the height of the triangle there. So we'll remember what's the total surface area of a rectangular, a square base pyramid? Good. You guys were explaining this before. What's the total surface area? Solina.
The base.
Mm-hmm.
The triangle times 4.
Yes, all right. So 4 times the triangle sides, all right? Okay, so what's the base area here? The base is just this one here, and that's a square base of side 2, so it'll just be 2 times 2. All right, plus 4 times, what's the formula for the triangle? Is 4 times, and then the base, which is the same thing, is at 2, that's just 2, times the height, which is 3 over 2, right? Base times height over 2. Remember, a triangle is base times height over 2. Okay, and then you just add it. So that'll be 4, and then you can, so before you multiply the values together, right? What do we do first when we see something like this? Before we multiply, we start with S.
Simplify.
We simplify, that's right. So simplify means you can take a number from top and bottom that can be divided by another number, and you can simplify both of them. So Alvina, which number would you take from the top? 2, correct. And the bottom? 2, correct. And then they divide, which means they will cancel off. So that will just become 4 times by 3 over 1, which is just 4 times by 3. Okay, which is 12. So the final answer will be 4 plus 12, which is 16. Is that centimeters? No, meters. 16 meters squared. Right, that's the final answer there. Okay, any question? No? Okay. All right, so I'll let you guys try the. Okay, you guys will try we'll do the now you try part, and okay, let's see, 1, 2, 3. All right, let's do the now you try, and then we'll move on for now. All right, so here, grab a piece of paper or your exercise book, either way. Please try this one out.
What?
No, all good. Just make sure you
Did
check
I
the
do
answer.
well?
So these two are multiplied together, right? But it's not that
Oh.
first. So you need to multiply this first. Remember Bond's rule, you have to do multiplication first and then the addition after. Right? So up to here is okay. But yes, you need to do this multiplication first. 2 times 5 times 6, and then you add to 25.
Okay.
Right? Because you have to do multiplication before addition.
Okay.
Always multiplication and division first. Okay, so let's move on to 5F, surface area of a cylinder. And in a cylinder, when you think about it, it has two parts, right? Two types of areas. The first one is the top area there, which is a circle, right? It's a cylinder, so it will be a circle. And then the bottom one will also be a circle, right? Yeah. Now the tricky part is how to figure out the area of the side, right? The side of the cylinder here. That's actually the tricky part. And the easiest way to imagine it is to imagine, let's say this is, have a look at this. Imagine the top and bottom is filled, right? So you see how the line around the top there is the circumference, okay? That's the circumference of the circle, right? And then the area of the top is the area of the circle. So when you expand this, expand the side of the cylinder, that whole surface area there is actually, the length of it is the circumference of the circle. Remember, it was a circumference, right? See, that's the circumference of the circle. And when you expand it, it becomes the length of the surface area on the side. And what's the width? Well, the width of it is actually just the height of the cylinder. Does that make sense? Right? So Solina, what is when you expand this? What's the length of the surface area? It corresponds to what part of the circle? This is the side, right? That's the side of the cylinder. Yeah. Imagine this is the cylinder, and this is the side of the cylinder. If you expand that fully, the length of the side surface area corresponds to what part of the circle?
The outside
Which is called the, start with the C.
circumference.
Yes, which is the circumference. And Alvina, the width of the side area corresponds to what part of the cylinder? The height of the cylinder. Very good. So yeah, so that's why the area, right? That's why the total surface area of a cylinder would be 2 times the top, right? 2 times the top area, because top and bottom is the same. All right, this top and that bottom is the same. So 2 times the top area plus the side area. Now the side area, you guys just figure it out. It's actually just the circumference times by the height of the cylinder. Okay. Yeah, and then the top area and the bottom area, what's the formula? Times what? If the top area is a circle with radius r, what's the area here? Alright, what's the area of the top surface? Anyone? Anyone? What's the formula for area of a circle? Starts with pi times r squared, correct? Pi times r squared. Or the formula is pi r squared. That's the area of a circle, right? So that's just be 2 times pi r squared, and then the side area is the circumference times the height. What's the formula for circumference? Solina.
What?
The circumference. The formula for circumference of a circle. It's here.
Oh.
2 pi r, okay? It's right in front of your face. So the circumference, which is 2 pi r, okay? And this is the circumference of the circle. Okay, so that's a formula. Now let's have a look at an example. I think they only have 2 examples. Okay, let's try this one now. Okay, so the first example will be so the first example is a straightforward one. which is just what's the okay? Maybe just try this one out for yourself. Okay, I'll help you guys get started first. The area is equals to 2 times the circle area. Right, circle area. Well, this one they turn it on the side, so there's no top bottom. So 2 times the circle area plus the side area. All right, and what's the circle area? 2 times pi r squared, and then the side is the circumference, which is 2 pi r times by the height of the cylinder. So I've given you guys the formula. See if you can figure it out, the rest of it. And this one you need a calculator as well. Who doesn't have a calculator?
Me.
You don't have a calculator. You don't have a calculator. Okay, all right. Yeah, you guys can use my calculators instead. Right, come help me pass it to Alvina. And then you can use this one here. Alright, so when you get to that point, just put the values in and see if you can get the right answer. Make sure you get the right values, yeah? Yeah, so for pi, make sure you use the pi here. See, there's a pi there, so that's yellow. So you're going to go shift and then that will give you pi. Okay? Make sure it's you giving the final answer in 2 decimal places.
How do I make it?
Yep, so press S to D, so that's 2 decimal. Avina, did you get the answer? Okay, good. So yeah, Selena, normally you would punch in like both of them all at the same time rather than just part by part.
Oh, okay.
Okay, but yeah, well, you guys should be able to do this this example. Then I'll move on to the next example. This is the harder one. Example 12. Finding surface area of cylindrical portions. So this one is a little bit trickier. Oh, actually, maybe I'll borrow the explanation as well. Okay, all right, have a look. For this example, right, this is a half cylinder. All right, it's not a full cylinder, it's only a half cylinder. So how do we find the surface area of this one? Now, note that for this half cylinder, you would have the 2 semicircles, right? 1, 2 semicircles, and then you only have half of the side area, right? So this side here, now we only have half of it, not the entire side, only half of the side. Okay, does it make sense? So you need to calculate the main one, and then you have it. Also, it has an extra bit, which is the bottom here. Okay, the bottom, because when you cut it, when you cut it in half, that surface I highlighted is this bit here. Okay, that is actually just the yeah. So that's the bottom bit. Where you cut it, it has that surface at the bottom. Okay, the blue part I highlighted here is the same as that blue part there. They're the same. All right. Which means the total surface area would be, I'll borrow the answer, 2 times the semicircular ends, right, which is that one there, and this one here, right, and then plus half of the rolled rectangle side. So it's the side of the rectangle rolled up. Oh, actually, sorry, my bad. The bottom one, yeah, the non-rolled up version is actually this area. Yeah, sorry, it's this one here. Yeah, that's better. Okay, but yeah, so half times the rolled up rectangle side, which is this thing here, right? It's like the one I showed you guys earlier. When you curl up the cylinder and when you expand it, it makes like a rectangle, right? Okay, and then the last one is plus the flat side, which is the slide I would just cut, which is that one there. That's the flat side. Okay, so okay, any questions so far? No, make sense? Yeah. So 2 times semicircular end is, just note that the circle is pi r squared, and then it's half a circle, so it's half of pi r squared, and then 2 times that. Okay, so that's 2 of the semicircular end, and then the rolled up rectangle. Remember, it's a circumference. This is essentially like your circumference times the height of the cylinder, right? But then you only want half of that. Okay, and then plus the flat side. Well, the flat side, when you look at it, this one is actually the diameter. Okay, this is the diameter of the circle. Because when you, if you were to complete the circle, it will look something like that, right? Okay, so that's the diameter of the circle. So in this case, therefore the radius is actually 4 divided by 2, which is 2, right? It's half the radius is half of that value there. Make sense? And then this value here is just simply the height of the cylinder as usual. Okay, so when you see the side at the bottom, it'll just be 4 times 8, and that's it's just a rectangle. 4 times 8, that's it. Okay, so that's a flat side. Now, so Alvina, I'll let you work on this question a little bit later, but we'll move on first to the next chapter. Okay, any question here at this point? Just understand the main concept, right? More practice will come afterwards. So that was okay. That's 5. Yeah, that's 5F. Next is 5G. Volume of a prism. Okay. Next is 5G. And then so last one is volume of the cylinder. That'll be it. Okay, next is volume of a prism. So volume is like the basic idea of, the essential idea of volume is how much space like an object takes, right? Okay, so so this is the main one. For solids with a uniform cross section, sorry, that one there. All right, for solids with a uniform cross section, which just means that the cross section doesn't matter where you cut it, it's always the same. So if I were to cut this one like around here, right? If I put a knife, okay, and I cut it right at this point, the cross section will look the same. It will be something like that. Okay, and well, you don't see this, I'll put a dot behind that. Does it make sense? Right? It's like if you have what's the best example? I think cylinder, these ones are actually the best example. So if a cylinder, if you keep on chopping it up, or like a sausage, right? If you keep on chopping the sausages up, the surface area of the sausage will always be the same. Okay, so that's what it means by solids with a uniform cross section. Uniform just means the same, and cross section is a section where when you cut it, you see the cross section of it. Alright, that's what cross section means. So similarly, that shape there also has a uniform cross section. So the volume is very simple. Volume is just area of the cross section times by the perpendicular height. Selena, remember this one? We did this one last year. Maybe.
No,
Hopefully.
I do.
You do?
Yeah.
Yes? Okay, so it's the area of the cross section, that one there, and then you just multiply that by the height of the shape. Okay, so let's get to one of the examples. Alright, skip these ones. Alright. Finding volumes of prisms and other solids. Okay, so this one. What is the area of the cross section for question A? So volume is the area of the cross section times by the height. Alright, so what's the area of the cross section for question A here? What's the shape of the cross section? Alvina, what's the shape of the cross section? So if you cut it on the side, like here, what's the shape of the surface that you just cut? Square, correct. What's the area of that square? For this shape here, right? It will be this square here, and note that this it will be always the same. So the top will be the same as the bottom, which is 1, correct? It's just 1 times 1, right? In this case, it's a square, so that'll just be 1 times 1, and then times it by the height, which is 3. So that will just be 3 centimeters cubed. Okay, make sense? Yeah. Now, question B. The volume is the surface area times by the height, and they already gave you the surface area. Now this is an irregular shape, so you don't know how to calculate this area here, so this just gives you the area straight away. All right, so volume is the area of the cross section times by the height. Okay, and that would just be 10 times 5, which is 50 centimeters cubed. Just multiply the two values together. Any question? No? Okay. Last one. Now for this question here, for this question C, right? How do we find what's Solina? What's the shape of the cross section?
Triangle.
Triangle, correct. What's the area of a triangle?
Base times height divided by 2.
Base times height divided by 2. Alvina, what's the area of this triangle? This cross section area? 6, correct. Area of the cross section times by the height. Now the area of the cross section, the base is 4, the height is 3. So that just be base times height, 4 times 3 over 2, and then times it by the height, which is 6, right? So this is the height of the shape. Okay, so recognizing which cross section, which surface is the uniform cross section will help you find out. Okay, find that surface area and then just times it by height. Easy. So yes, it is 6 times by the height, which is 6, and that the answer will just be 36 centimeters cubed. Any question? No? Okay. Hopefully that gives you guys an idea on how to do these questions. And yep, that's the only example. So yeah, okay. No, I think I should be able to do this. So moving on, last one in terms of content. Last one is volume of a cylinder. Okay, let's see, 2 examples. All right. Oh yeah, okay. Yeah, the idea is quite simple. So the volume of a cylinder is essentially this one is also one of the shapes that has a uniform cross section. What's the shape of the cross section?
Circle.
Circle, correct. So this one has the cross section is essentially a circle, right? And Alvina, what's the area of a circle? What's the formula? Not quite. Area is pi r squared. Now, how do you remember area versus circumference? Just remember, what's the unit for area? Normally squared, right? It's like when you calculate the area, it would be like some xyz value and then centimeter squared or meter squared or kilometer squared, right? Note that it always has the square. Okay, the area unit always has square, always. Right? You never have an area unit without square. Okay, so area unit always has square, and that's why the formula for area is the one with the square. Does it make sense? Because there are 2 formulas, right? The other one is the circumference. The other formula for the circle is the circumference, and that's the one where it's 2 pi r. So note that 2 pi r doesn't have the squared in it, so that's for circumference. Okay, the one with the squared in it is for the area. Does that make sense? Yeah. Okay. So that's basically it. Well, so you get the area of the circle, which is pi r squared, right? And this is the uniform cross section, which is a circle. So the volume would be the area of the circle times by the height. That's it. So area of the circle again is pi r squared times by the height, which is h. That's it. Make sense? All right. Now let's try out the example here. So Okay, so for this one, use your calculator. Alvina, can you try question A and Selena try question B for me? Okay, and this is Alvina on A and Selena on B.
I forgot the formula already.
The formula is the area of the circle times the height.
Oh, okay.
Yeah. Remember, it's just the area of the uniform cross section times by the height. That's the volume.
Should I turn it on?
Just press on AC, I think. Yep.
Oh.
Okay, what's your answer, Alvina? 282 point is correct. Very good. So for question A, its area is pi times radius squared times by the height, which is 10. And yes, that is 282.74 to 2 decimal places. So Lena, what's your answer?
0.76 meters square.
0.76 meters squared is correct. Make sure, so Alvina, make sure you have the centimeter squared, yeah? Make sure you have the unit, otherwise you lose marks in the exam for that. So yes, sorry, it'll be volume, not area. So volume is, for question B, is pi times radius, but note that this is a diameter, so then radius is half of that, which is 0.9. Well done, Solina, for picking that up. Alright, so that will be times 0.9 squared times by the height, which is 0.3. Alvina, any question there? No? Okay. And then calculating that, 0.76 meters squared to 2 decimal places is the answer for that one. Okay, so that's question, example 15. Not too bad. Now, how about the... oh yeah, so this one, when they ask you for something like capacity, it just means volume, right? So capacity is how much it can contain, and essentially it's just calculating the volume, because the bigger the volume is just literally means capacity. That's essentially what it means, right? And that's why when you're trying to find the capacity of, in liters, of something with radius 30, so R equals 30, and then height is 90, so H equals 90, right? And again, this is a cylinder, so that will look something like that, and then that's the radius, and that's the height. It will be the same thing. It's just the surface area of the circle, which is pi r squared times by the height, right? And you just got the value, radius is 30, height is 90, punch into the formula and get this one. They asked you to the nearest liter, alright? And you have to convert from centimeters cubed to liter. How do we do that? Well, there is 1000 centimeters cubed in 1 liter. This is something you just have to remember. Okay? The easiest way to remember is 1 milliliter is 1 milliliter is 1 centimeters cubed. Just think that. Okay? So note that 1 liter would be 1000 milliliters, right? Okay? And that's why it's also 1000 centimeters cubed. Does it make sense? Yeah? So the easiest one is 1 milliliter is 1 centimeters cubed. That's it. Just remember that. Okay? 1 milliliter, 1 centimeters cubed. And the rest you have to work it out through conversion. Okay? So normally you have to remember one of them, and then the rest of it you have to learn how to convert between the different units. And liter, between liter and milliliter, is just 1000. It's that when you have meter, 1 meter is how many millimeters? 1 meter has how many millimeters?
100. What?
1000.
1000.
1 meter has 1000 millimeters. So remember the main unit. Okay, so if you have whatever the unit, let's say meter, right? When you go to millimeter, it's times 1000, right? And then the unit above that is kilo. So kilometer, 1 kilometer is 1000 meters. Okay, so kilo is the unit above the 1000 ratio above meter, and then milli is the 1000 after the main unit. Okay, so when you have milliliter and liters, liter is 1000 times of the milliliter. Any question? No? Okay. So yeah, okay, so that's it. That's it for now. We'll take a, let's see, what time is it? Oh, okay, all right. We'll take a very short break. Okay, we'll take an early break today, but then the second half, so Avina, for the second half, I just want you to continue working on these questions, yeah? Because your exam is next week and it covers all the way up to 5H. So just continue working on the questions, and then in the second half, oh yeah, I haven't given you guys out the cylinder one yet. So that's your cylinder one. Okay, yeah, so in the second half, Selena, I'll go through your assignment. Okay, your laptop charging up. Good. Alright, let's take a short break.